Alright, so looking at equivalent expressions, all you're really looking to do is to simplify what you see. So powers, fractional powers, in fact, let's get a little bit of review. The square root of 9 is what? 3. The square root of 9 is what? 3. So I can write it both ways. When nothing is there, an understood 2 is supposed to be there. Okay? Because 9 raised to the 1/2 power is the same as 3. Okay? 1/2 is the same. This fractional power is saying the same thing as the square root. The power goes right here. 9 raised to the power of 1. The root goes on the outside, right here where the gray is lined up. So when you see 9 to the 1/2, it's the same as the square root of 9. You get 3. Okay? Now, this one has 5/12. And this 5/12, the way it's written, it's going to apply to both the numerator and the denominator. So my numerator piece and the denominator piece will both absorb this fractional exponent of 5/12. We talked about this last time, I believe. What happens when you have, anyone, a power raised to a power? What do you do with those numbers? Multiply. So we're going to multiply -8 and 5/12. Now I know we will have a calculator for ACT, but for other skills that you do on the questions for speed and accuracy, I like to have you guys learn this by hand. Because if I multiply those, I know 8 and 12 can reduce to what? 4 and 3, right? Or, careful. 2 and 3. Because you divided both by 4. Okay? So this would be a 2, this would be a 3, so that the leftover pieces that are multiplied are going to be a -2 multiplied with a 5 and a 1 and 3. So that you get a -10 over 3. You'll see what I did? Okay, so the -2 and the 5 multiply to get a -10. The 1 and the 3 multiply to get the 3. So that is what we get for the top. So w to the -10/3. What do we get to the bottom? Well, we're going to multiply these. We're going to have a power raised to a power. We're going to multiply a -4 and a 5/12. Same thing over 1. These will reduce to what? 1 and 3. So what's my answer? -5/3. So this is w -5/3. Can y'all tell me what I do next? I can flip them, right? I can flip them. Another thing with fractional bases like this is that you can subtract the powers. If you wanted to, you could say w to the -10/3 minus a -5/3. Right? But you would end up adding. Or you can flip these and say w to the 5/3 goes on top as a positive, w to the 10/3 goes on bottom as a positive. So negative powers, we always move across the division sign. Okay? And their term goes with them. Okay? So what does this mean? I have 5/3 on the top, 10/3 on the bottom. If I subtract here, it will look like 5/3 minus 10/3, which I get what? -5/3. So w to the -5/3 is all of this simplified out, which looks like it would be that one. Because the negative means it's going to go downstairs as a positive 5/3. The roots, which are below ground, are going to go, oh, that might be wrong.
No, that's what I got to. Oh, wait. No,
it's A.
Yeah.
It's A. It's going to be over here. And then the power is above ground level. It's going to be right there.
Yeah.
So A would be the answer. Cool. Are we good? What I think you should have done, and I did that just for algebra practice, I wouldn't have done it that way at all. What I would have done would have been the parentheses first, and then did the 5/12. Watch. The 4 goes upstairs as a positive, the 8 goes downstairs as a negative, or you know what I mean, and then we would simplify that. There's 4 W's up top, there's 8 on the bottom.
Take away the top.
Who wins? The bottom by how much? 4. So I'm raising this to the power of 5/12. So that means this will apply to the top, and that's just 1, right? 1 to the 5/12 is like 1 raised to the, do you see what I'm saying? What's the 12th root of 1? 1. And what would 1 raised to the 5 be? 1. And then this one would be, this is now raised to the 5/12. So what's 4 times 5/12?
5/3.
5/3. So I get 1 over W 5/3, which again, there's a 3, there's a 5, a lot less work. Okay? Questions for this? Alright, come up with another question. Any of them that you want to look up at. So vocab is a big piece. We have to know what we're reading, what we're looking at, because ACT is a test where either you know it or you don't, okay? So real quick,
Okay,
this is on chapter 10, and I believe it's the second page of chapter 10. Let me see, page 100, okay? So page 100, yes, you can fill this in as you go if you would like. What are the positive integers that you see? What would I list out?
2, 3, 12, 16, 18.
Perfect. So now someone different. Negative integers. What negative integers do you see? Come on, guys. What negative integers do you see? Don't be afraid to make a mistake.
Negative integers.
Yep.
1996.
Yep. Negative 81, negative 19, negative 9, and negative 6. Why didn't you say negative 1/4?
Because it's not an integer.
It's not an integer. It's a fraction. So now, odd integers.
Oh wait, for number 1, wouldn't you list 0 and 1.75 since it just says numbers?
So it says the positive numbers. The reason why I didn't put
0.
Oh, you're right. So we should have put 1.75. Nice catch. We
But
should
not
have,
0.
but not 0.
Zero.
0 is not a positive nor negative.
Okay.
Okay, yeah, neutral. So odd integers. What do you see up there that's odd? Negative 81. Keep going.
19.
Yep.
-9.
0.15 is odd. Yeah, you could see it as odd. Let's go for the integers though, because it's just looking for that, the whole numbers. 3 and 81. Cool. So on and so forth. Even. Okay, so now let's look at positive even integers in consecutive order. Positive even integers in consecutive order. What do I list? Because positive will be over there, right? Even will be the even numbers that you see. And in consecutive order will be 2, 12, 16. And what are the numbers that are neither positive nor negative?
0.
It's just 0. Okay? Alright, so now, what is the reciprocal of negative 1/4? Negative 4 or negative 4 over 1. Okay, that's a reciprocal. What's the negative reciprocal of 2? Negative 1 over 2. Because 2 is understood to be under what? 1 by default. When a number and its reciprocal are multiplied, give me a number, any number. 4. What's the reciprocal of that? 1/4. And if we multiply these, as this is saying, or the product, what do I get?
1.
1. Always. A number times its reciprocal will always be 1. Yes?
So why does it say opposite reciprocal? Why doesn't it just say just like reciprocal?
Because an opposite reciprocal, the context that you will see that is when you have equations of lines that look like this, And let's say that the line was like y is equal to, has a slope of, let's say, 2, and a y-intercept of like 6. You with me? And if I drew another one, let's say that I wanted to draw a line that was perpendicular to this, I could have something that looked like this. It doesn't have to happen here at the y-intercept. It doesn't. It can happen anywhere. It could have happened like over here. But here, what I can say is the blue equation would be negative 1/2 plus 6. It still is occurring at a y-intercept of 6. And the negative 1/2 is down 1 over 2, down 1 over 2, down 1 over 2. Where this positive was a up 2 over 1, up 2 over 1. The negative reciprocal is the negative flip of that slope.
Okay.
And it will meet at a 90-degree angle.
Alright.
So when you see that, which you will, it's whenever it's asking for the perpendicular slopes to lines. Okay? How many times does 2 go into 15 evenly? 7. How much is left over? 1. What is 15 divided by 2? 7.5. What's another way you could write that?
Or 15 minutes.
Not 7/2, but 15/2, right? Or, I see what you're saying now, 7 1/2. And if I convert this to an improper fraction, you know it's, yep, Texas two-step, 2 times 7 is 14, plus the 1 is 15, so it'd be 15 over 2. You good? Got to get the fundamentals out of the way for sure. All right, so let's keep going. These are important. Factors of 12. What are the factors of 12? 1, 2, 3, 4, 6, and 12. Nicely done. Because look, 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. You got them all. Okay? Now if I said list the first multiples, Tyler, what are multiples? Okay, so multiples of 12. So the first multiple of 12 is 12. What's the second multiple of 12? 24. Okay? And then, anyone, what would I get? 36. So think of, right in the combine, whenever they were drafting NFL football players or whatnot, they have the running the 40-yard, the 40-meter, whatever that is, right? They also have the broad jump. They have the high jump. So that broad jump, one of my former students who's now playing for the Indianapolis Colts, Ben Vandergoo right now, defensive lineman, his broad jump was phenomenal, and it still is phenomenal. He's a rookie this year. But my point is, a broad jump, to me, is like a multiple. Okay? Each broad jump that he's doing is 12 feet. So he can do 12. The next one will be 12 more to get to 24. The next one will be 12 more to get to 36, so on and so forth. So multiples are that.
Would you count 12?
Yes. So listen, when we get to this right here, we'll be talking about something here in just a bit that I want you to make sure that you understand what least common multiples mean. And it all depends on, do you know what that word means? Okay? Yeah, it's pretty far. Yeah, it's pretty far. Okay. So with that being said, what was I saying? Let's go to the first 4 multiples of 12. So we have 12, 24, 36. Tyler, what's the last one, Tyler? 48. All right. So list the factors of 30. Devin, what did I get for the factors of 30? 1, 2, okay, 1, 2, 3.
5, 6, 15, 30.
And you got them all just to make sure. I have 30, 30, 30. Oh, I forgot to write. That was my bad. 10. And then 5 and 6. Cool. List the first four multiples of 30. first four multiples of 30?
30, 60, 90,
Yep, because you're just broad jumping 30 feet each time. Okay? So is 12 a multiple or a factor of 24?
Yes.
No, which one?
Oh.
Which one? Is it a factor or a multiple? You gotta know the difference of 24. It's a factor, yeah. Because 24's multiples are 24, 48, 72, so on and so forth. Okay? Is 8 one of the factors of 64?
Yes.
Yes. Wait, what? But not.
Yeah, you
Said
get
I
it
learned
from
that from
Minecraft.
Minecraft.
Oh, nice, yeah.
Oh, yeah.
So, me
Same
too.
right there.
What is the greatest common factor? Listen, the greatest common factor, not multiple,
Oh,
of 27 and 45. What's the biggest number that they have in common? 9. Okay, you would have 1, 27, 3, 9. That's it. And then 45, you'd have 1, 45. You'd have 2, 3, you'd have 3, 15. And then you also have what? What's with 9? What multiplies with 9 to get 5? So the biggest one that they have in common, aka the greatest common factor, is going to be 9. Okay? What's the greatest common factor of 9 and 36? 9. Alright, here we go. Those were easy. This is the one that people struggle with right here. What's the least common multiple between, and these are frequently asked because people mess them up. What's the least common multiple, don't be afraid, of 9 and 12?
36.
36. And the way we do that is we broad jump. 12, 24, 36. Each is by 12. We broad jump. 9, 18, 27, 36. Each broad jump was by 9. But the least common multiple was 36. Okay? What's the least common multiple for 24 and 48? 48. Nice. Good stuff to know. Okay? You will be tested over those questions for sure. Alright, so here we go. We're going to look at prime factorization. Just a fancy word that means to break something down. Break it down. It looks big, it looks giant, I'll break it down. Okay? So I'll break it down to 2 and 9. Then I can break down the 9 into 3 and 3. Can you tell me why is it that that's where we stop? And that we write this, or 3 squared times 2. Why do we stop at 2, 3, and 3? Can't break it down anymore. Because it's trying to break it down to the prime numbers. You with me? 2 is 2 times 1. Can't break it down any further than that. 3 is 3 times 1. Because a prime number is itself times 1, and these cannot be the same number. So what's your lowest prime number that you start with? 2. You start with 2, that's your lowest. And then, let's go for like 10 numbers. We'll do prime. 2, before that, 3, 5, 7, 11, 13, 17, 19, right? And not 21 because it's 7 and 3.
Oh, that's right, yeah. So it'd be
23. That's good enough. Those are primes, okay? 1 is not a prime number because they can't be the same. They have to be different. Alright, so let's go on to prime factorization of 36. 36, can it be divided by 2?
Yes.
Yeah. It's 2 and what? 18. Can 18 divided by 2?
Yes.
Yes. So 2 is the easiest one to do this with, right? And then 9 can be broken up to what? 3 and 3. But here's what I like to teach you right off the bat. Let's pass this and go stronger. Prime factorization is looking at square roots of individual pieces. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and so on and so forth. 25 5, 36. You see what I'm doing? So here, what could I prime factorization? What could I simplify that? If I asked you simplify this, what would you get?
6.
Just 6, right? This would be just 6. Let me give you a different one. What if I said 54 square rooted?
You'd have to break it down.
Let's break it down a little bit, just a little bit first. 2, 27. You agree? Okay. Let's break it down some more. 9 and 3. This can come out right now, can it? What can the 9 come out as?
3 squared.
Or just 3, right? So I'm going to take the square root of 9 all by itself, where it comes out as 3, and guess what's left inside? 6. So this would be 3 root 6. This was just an example off the side. You with me? Now, if these are prime factorizations, what's the answer to number 5? 10. What is the product of the distinct? What does that mean? We talked about that, I think, last class.
Does that
What
mean-
does distinct mean?
It just means like that number, right? So it'd be just 2 and 3.
It doesn't mean that number per se. Distinct means like you have distinct eye color, distinct hair, distinct
That's
voice.
just like a definition.
It's a unique, different, not the same like other people. Okay, you're different. So distinct, I have 2 and I have 3. Even though 2 is repeated twice and 3 is repeated twice, my only different numbers are 2 and 3. So what is the product of all the distinct prime factors? What would I put? 6. Okay? You have to know the vocab because they will not help you with that vocab. All right. Here we go. What is the square root of 1? 1. What is negative 1 times negative 1? 1. How about if I have it 3 times? Negative 1. What is the square root of negative 1? I. Imaginary number. Just I. So here we go. One that I want you to memorize is square root of negative 1 is I. So what would I squared equal? Negative 1. Because you square both sides. And this is the one that I memorized because this stands out to me more. How can you ever square something and get a negative 1 or a negative? Okay? Either way, memorize both of those, please. All right, so what real number could you square to get a product of negative 1? None. You can't square anything. The only thing that you can square to get a negative 1 is I. Okay? All right, so let's go to here we go. We are going to distribute, otherwise FOIL 2 plus I and 2 minus I. What do I get? What do I get if I FOIL this out right here? What's the first terms that I get? Let's do this FOIL together. The first, I get what? 4. The outside, I get what? Minus 2i. The inside, I get what? Plus 2i. And the last terms, I get what? Minus I squared. Guess what happens to the 2 i's? They cancel to what number? 0, because they are adding and subtracting. You with me? When I multiply or divide, I cancel to what? 1. So multiplication and division will cancel to 1. If you learn this, it will help you with other things. Addition and subtraction will cancel to 0. So what this is leaving me with is that, but that's not my final answer. It's not, oh yeah, it's 5. Because I squared is negative 1. Okay? So this one you have 3 plus I squared. That means you got to write this out 2 times because of that 2 right there. If it was 3, you'd write it out 3 times. And let's distribute this. What would I get? The first one is 9, and then 6i. Yep, because it's 2 of these 3 i's. Plus I squared. So yes, minus 1. So minus 1, 9 is 8. So you're left with 8 plus 6i. If you have a question, please ask. Copying down notes and not understanding it is not fun, okay? So please ask me if you have questions. Let's move on. Let's go to exponents. So we got a little bit of practice with delta math on this video at the beginning, dealing with more difficult problems than this. That means you should be able to crush these, okay? Let's go around the room. Sorry that I don't have all your names memorized, so I'll just look right at you, okay? What's the first one? So look at me, please. What's the first one? And if you get it wrong, I'll fix it.
X to the power of 6.
Close. X to the power of 5, okay? Because when you are multiplying with the same base, it's the same as adding the exponents. Next, we're still trying, okay? Try and learn. What's the answer here? For number 2.
X1.
It's just x, right? X to the power of 1. Shortcut on that. When I'm dividing, you can subtract. I like to play a little 4v3. Those cancel each other out, and I'm left with 1 up top. Okay? Thaddeus, x to the power of 12. Because a power raised to a power, you will multiply. And a good way to see that is right there. We know parentheses usually means multiply. Devin, what do I get?
12x to the 5th.
12x to the 5th. He did independently each one. Forget. Alex,
Number 5, 8x to the 6th.
8x to the 6th. And now when I point at you, please tell me your name. That was rude of me. I apologize, guys. Tell me your name so I can learn it faster, okay? So 8x to the 6th is perfect. Because he did 2 cubed to get 8. And then he did x squared cubed to get x to the 6th. Tyler?
3x to the 4th.
Perfect. 3 because he got 9 divided by 3 is 3. And 6 up top, 6v2. Who won? The top by 4. Okay? Colin, what is number 7 going to be? Something v something. Someone help him out. What would the answer be? X cubed, right? X cubed. Because the top would become 7,
Oh, and then you just subtract it.
and then you subtract or say 7v4. Who wins? The top by 3. Cool. Alright, so now let's do a little bit more, because this, I'm not even kidding, this unit is huge. Very, very important, these fundamentals. Everyone, what do I get? Yes?
Never mind, I'll ask it when it comes up.
Okay, no worries. What do I get for number 1?
1.
1. Because they cancel to a form of 1. How about number 2? 1. Okay. So anything to the power of 0 is going to equal 1. The only things that this doesn't work with, so anything, as long as that anything is not 0 or infinity. Everything else that you can possibly think of, when you raise it to the power of 0, you get 1. Okay? How about here?
1 over x to the 5th.
Yep, 1 over x cubed. Which could also be written, what we talked about with delta math, like this. So what would this be written? Oh, I just did, right? Same thing. 1 over x cubed. X to the 1 is x. 1 to the 5/13? 1. Careful. 0 to the 6/19 is 0. What's this?
1.
No, that's 619 degrees. No, I'm just joking. It's 1. It's 1. All right. So negative 2 squared.
4.
Positive or negative?
Positive.
Positive. Negative 2 cubed.
Negative 8.
Negative 8. Ooh, how about this? It looks like 8, but it's different.
Oh. that's right.
Negative 4. Because PEMDAS says we will do the exponent first, then we will multiply by a negative. Where here we did the parentheses first, then we did the exponent. Okay, so this one on number 8, it's like this. Negative times a negative would be a positive. All right, 11. 1/4, because you apply the 2 on both of them.
4 9.
4/9 on the bottom. Questions? Oh, you good?
I just have to look at it.
Okay.
I got it.
Let's keep going to okay. Back where's your name again? Say again, Grant. Grant. What is number 1? Okay. He's saying, and he's close, if they were multiplied,
Oh.
it would be x. Because multiplication, it's like saying I have 2 of these. And this, oops, is quadratic, which squares it, and this square roots it. Those cancel to a form of 1, and you would just be left with x. But this is adding it.
Would be 2 square root of x.
It'd be 2 square roots of x. Okay? Real quick, let me help you out with this sheet, because this sheet is a little bit expensive. Confusing. Why is it expensive? Alright, so 2 pencils plus 3 pencils. I'm not trying to trick you. Equals how many? 5 pencils. Yes. So, ready? This is the same as 2x plus 3x. 5 pencils. With me? Because it's the family of x. It's the same as 2 square roots of x plus 3 square roots of x. These are the pencils. So when I have 1 plus 1, it's 2 pencils. You see what I'm trying to do with you guys right now? Alright. So what would the next one be?
8x. Or 8 square root.
8 square roots of x. 8 pencils. Can I do that with this? No, because I don't have pencils. I have, like if I were to ask you, what are 2 pencils and 3 In-N-Out double cheeseburgers? I'm hungry right now. And if I were to add those together, what would I get?
2 pencils
2 pencils
and 3.
and 3 In-N-Out double cheeseburgers. You can't add those together. They stay separate. They're different families.
You can factor out the x though.
You can factor out the x if you would like and put this, or leave it exactly the way it was. Okay? Here we go. That's when you're adding. This is when you're adding stuff. Nice one. Now you're going to multiply this. When I have something that's square rooted multiplied with another square root family, they all have their own roof, if you will. They're all going to come over under the same roof. Okay? Can you tell me why? Okay, so let me help you out. Dinner party. Here we go. What is 2x raised to the power of? Well, we talked about this today. What is 2x raised to the power of? 1/2. What is y raised to the power of? 1/2. So this is the same as if I were to go backwards and apply it to like both of them. You see what I'm saying? So that's why you can bring them all together into one, just like that. So what would this be? The square root of
Would be x, the square root of 1.
x squared underneath, right? Or you guys jump up a little step forward, no worries. And then this will come out as x, because I can take the square root of x squared. And if you struggle with that, guys, this is how I tended to help people out. X squared, there's 2. What number is understood to be there that we've talked about already today? 2. If it was a 3, pairs of 3 would come out as 1. Here there's 2. Pairs of 2 are going to come out together holding hands just like a little couple, and they're going to call themselves the X couple. Okay? So X root Y. So enough of variables, let's look at numbers. So 4 root 12 times 2 root 13. What's under the house? 36. What's outside right now? In cold weather. That was a joke. Anyway, so what is my final answer going to be? 48, because 6 times 8 is 48. This square root can be also brought in together into one mega square root when there's division going on. You with me? So what's the inside simplified to? 36. And then I get 6. And now, this is a square root, and I ask you, do I apply it to both of these the way I did the other ones? I won't. If I was multiplying right here, then I could. But I'm not multiplying. So it's exactly what you would see. It's the square root of the square root of 529 minus the square root of 361.
So you can't do the 4th.
Oh yeah, you could, wait, say again?
4th root?
No, because of the addition and subtraction.
Oh, okay.
Okay, if it was multiplication in the middle, then you could apply it to both of them, and like have the 4th root to that one and the 4th root to that one. If it was multiplication. But let's see, what's the square root of 529? We don't know that, do we? 625, 25, 2, 4, 2, 2, 4, 4, 4, 2, 3. Yeah, we don't know that. But we do know 361, right?
I'm going to guess 17.
You can use your calculators, guys. This is square root of 361. 19. What's the square root of 529? 23. So we could do it like this. 23 minus 19. 4. I get 2. Power parentheses. Okay? Alright, last but not least, before we leave, we can either do these drills or 100 push-ups, since we didn't do the reading homework. Push-ups? No, I'm just joking. We're not going to do push-ups. What is the product of the distinct prime factors of 54? The distinct prime factors of 54, we need to break this up. I'm going to divide it first by what? 2, 27. 9 and 3. And then 3 and 3. What is my answer going to be?
C.
C, 6. Because it's not the multiplication of all of these. It's the ones that are different. 6. You with me? Okay. If x is the least odd prime number and y is the least positive integer that multiplies to get the 10, what is the difference between x and y? We want to know this. We want to know what is x minus y, but we first have to find out. X is the least odd prime number, and y is the least positive integer multiple of 10. What's the least positive integer multiple of 10?
Do you give me 10?
10. And x is the least odd prime number. What's the least odd prime number? 3. So if I do the difference between them, get 7.
Okay.
We have this negative 2 is going to apply to both of them. Sorry, those were sneezes. So negative 1 raised to a power of negative 2 will become a positive 2. The negative 3 times negative 2?
-6.
Positive 6, right? No worries. X to the power of 12 and y to the power of 21. So the x's will become what? 14 and 27. Yep, scan the answers. Find that one answer and go for it quickly. Number 4, in the complex numbers where I squared is negative 1, which of the following is equal to the results of squaring this? So let's square this real quick. Multiplicity of 2. What is my first term?
-1. Or I guess.
I squared. Outside?
4i plus 4i.
So 8i. And then the last term?
16.
16. You said this is negative 1, this is 16, so I have a 15 plus 8i.
That's fine.
And what is the least possible sum of 3 distinct prime numbers between 10 and 20? So let's list out all the prime numbers first. Between 10 and 20. What are they? 11, 13, and 17. And these are the 3 distinct, and they're the least possible sum. Because we know 19 is there too. But we don't want this one to be included in the 3 that we're doing. We don't want to do like these 2 and this one. We want the least sum possible. So I have 20, 20, 30, 41. Okay? You agree? Yep. Guys, please read the chapter, because what we just did, you needed to do for homework. I want you to come with great questions so you refine the learning and you've mastered it when we're done in class. Not kind of still working with it, okay? Please, read the reading. So what's your homework? Read chapter 11 and Delta Math. Please read before doing Delta Math. All right, I'll send this through text.